Hey everybody! Happy Friday! Woo! 1 week till the big day. I'm super excited, and because of that, I hope you've enjoyed kind of this nice little jog through Unit 5. Today we're going to talk about shifts of absolute value functions, but this is, I think, going to be the last video that I put up for you guys until after Christmas break. Next week I have some activities, which I'll post for you guys. But no like instruction. Unit 5, this is kind of it. So, like I said, we're not going to test over and anything. We're just going to kind of take a peek, see what's out there, that kind of stuff. And then when we come back, we're going to be doing exponential growth and decay, which is pretty important stuff. Let's talk about shifts here. But if I don't see you anyway, have a super great Christmas and all that jazz. And yeah, woo. So let's talk about some shifts. So we did we did linear shifts earlier, right? Where we talked about how it would move vertically or horizontally. And so we know the parent function, right? Y equals the absolute value of x. That's just going to be our v. Maybe I'll just keep it over here so we can kind of keep referring to it. So looks like this, right? Let's graph it real quick here. There's the absolute value function. So our parent function is going to look like this. So what kind of things can we see that are going to happen to that parent function that are going to shift and slide this thing all around here? Well, we talked about stretches already, right? If there's a number in front of here that's greater than 1, it's going to make it go up steeper. Something like, like this, where it's going to go up at a quicker rate, correct? And if it's a number less than 1, like a fraction, then it's going to make it go out wider than it normally is. And if we throw a negative in front of there, we talked about this in class, I'm not sure if we talked about it with you guys at all, but if we throw a negative out in front of there, what we noticed on our homework was that it went down. So that's just going to reflect it over this x-axis here, kind of flip it, if you will. So let's talk about vertical and horizontal shifts. A vertical shift is going to be just like it was with linear functions. It's going to be out here. So if we have some number that we're adding or subtracting out here after the absolute value sign, what it's going to do is take the same v and it's going to shift it. So this would be shift up 3. Right? I'm going to take the same function, try my best here, and go up 1, 2, 3. And it would look like that. Same exact thing. We're just going up 3 units. And now my vertex, instead of being 0, 0, would be 0, 3. Right? So we could do vertical shifts. Likewise, if I threw a subtraction in here, wish my board was a little bigger. Y equals absolute value of x minus 5. This would go a shift down 5 units. So again, same idea. Only now my vertex is going to go 1, 2, 3, 4, 5 units down. And look like that. The same graph, only we're going down 5 more units, right? So the number on the outside, that's going to kind of show what that's going to do. Cool. What about a horizontal horizontal shift. Let's talk about that. Well, just like it was with linear functions, I'll tell you what, I'm going to move that over here. Y equals absolute value of x. So we know what our parent function is, right? If I throw, let's see, horizontal. So if I throw a number inside of the absolute value, like that, that's how we're going to get our horizontal shift. So notice, remember, it was like inside the parentheses before? Remember, the absolute values are just like parentheses. So this one is going to work the exact same way it did before. So remember, this inside showed you the opposite sign, right? That's tricky. It's the opposite sign of the shift. So if I see a -4 on the inside, that's going to be a shift right. That's not how you spell right. There you go. 4 units. So if I see x -4, the absolute value, what that's going to do is take my v, and it's going to move my vertex 1, 2, 3, 4 over here. And then I'm going to have my same v that I had before. It just went to the right 4 units now. And then obviously, if I do the same thing, only I have to throw a plus sign in there. That's not a parenthesis. That's an absolute value sign. That's going to shift to the left 6 units. Left 6. And I can throw that one up there in red if you want. I'm not even sure if I want 1, 2, 3, 4, 5, 6. And there's my vertex. I'm trying to match the slope. Something like that. Right? So those are kind of my shifts. They're very similar to the linear shifts, which I think is why we learned about that, because, excuse me, because we're going to relate these shifts every single time we learn new stuff. There's going to be related shifts that are very similar and kind of help us to figure out. I'm trying to block that glare for a second. I got mad glare right there. What those shifts are going to look like. So, with that said, now that we know what those horizontal and vertical shifts are, I want to talk to you about something called vertex form. Because vertex form is going to be very similar in all the things we learn about too. And that's going to look like this. Y equals A absolute value x minus h plus k. All right? Basic vertex form is where, like, usually if we have like A, it could just be 1 or something like that. We don't really know. But the most important players here are the h and the k. So here and here. Those numbers are going to give us the vertex negative h, k. So it literally, if it's written in this form, it's literally going to tell you what your vertex is. So remember when we were making these tables, right? And you had to kind of find that like line of symmetry so that you knew like where you wanted to see both sides. Well, if you already know what your vertex is, that's like the hardest part of this whole thing. Because now you know that's where you can go off from both sides and it will be symmetrical and it will make your life really, really easy. So let me show you for example, right? Oh, notice, why do we have minus h in here? Because this sign is always opposite, right? So if this said, well, I'll show you in a second. Let's do that. So, I'll do it in black. Let's say I have the equation y equals the absolute value of x minus 9 minus 4. All right, it's in the exact same form. We don't have a number that's going to stretch it, so it just must be 1. And notice I have those numbers, right? -9, and I have a -4 on the outside. So, because it's written in this way, it's kind of like slope-intercept form. Vertex form just tells me the vertex. So my vertex here, I look on the inside, that's the x value, but it's the opposite sign, 9. And I look out here, and that would be the y value, -4. And so this thing is going to have a vertex at 9, -4. And then I can, you know, if you wanted to see what it would look like, I can make my table from there. And I could go 7, 8, 9, 10, 11. And it should be symmetrical as I go out. Pretty awesome. Let's try another one. So if I had y equals -2 times the quantity x plus 17 plus 11. All right, we have vertex form because there's nothing crazy going on here. We do have an a value here that's going to stretch it, and it's negative, so it's going to flip it, which is fine. We can still find our vertex. So we look on the inside, the h value, as we might call that, in this case, is 17 plus 17. So really, we got to flip that when we put it in. So it'd be -17 for the x value. And then the k value on the outside is going to give me the y value. And that's going to be the vertex, -17, 11. And you guys are probably thinking like, wow, that looks really easy. You'd be surprised how awesome this is, like how much time that's going to save you. It's pretty awesome and amazing. So, yeah, I hope you enjoyed your little journey through Unit 5. We're not going to test on it. And, yeah, cool. When we come back, we're going to jump in hard with some 3 units that are super important. Try to get through all of them in the 3rd quarter. And then we'll see what else we can do. We got air testing in there. I'm kind of excited to be, you know, talking about the 2nd semester. Yeah, awesome stuff. All right. Hey, you guys have an awesome Christmas break. Be awesome, be safe, and I'll miss you. I'll see you later.